The composition of coal varies widely, and hence it is necessary to analyze and interpret the result from the point of view of commercial classification, price fixation, and proper industrial utilization. Coal is assessed on the basis of the proximate analysis and ultimate analysis. In proximate analysis, we analyze moisture content, volatile matter, ash content, and the fixed carbon. In ultimate analysis, we analyze the percentage of carbon, hydrogen, nitrogen, sulfur, ash content, oxygen. Then detail of proximate analysis. Known weight of coal sample is taken in silica crucible. Then the crucible is heated in electric hot air oven at 105 to 110 degree centigrade for 1 hour. The crucible is then taken out with the help of tongues cooled in a desiccator. Cooled in desiccator and weight. The process of heating, cooling, and weighing is repeated till the weight of crucible containing anhydrous coal becomes constant. Then loss in weight is repeated as moisture on percentage basis. Then the formula will be percentage of moisture content loss in weight into 100 upon weight of coal sample taken initially. You can also see in the slide loss in weight of sample upon weight of coal sample taken for the heating into 100. Then volatile matter. In this dried waters volatile matter, the moisture free coal is taken in silica crucible and covered with a lid. The crucible is placed in a muffled furnace at 925 plus minus 20 degrees centigrade for 7 minutes only. The crucible is then taken out and the first cooled in air, then inside a desiccator and weighed. Again, loss in weight is reported as volatile matter on the percentage basis. Then the formula will be loss in weight of the coal sample upon weight of coal sample taken into 100. Loss in it means loss in weight due to removal of volatile matter from water. Then ash content. After the removal of moisture and volatile matter, the residual coal left in the crucible is heated without lid in the muffle furnace at 750 plus minus 50 degree centigrade for half an hour. Heating, cooling and weighing is repeated till a constant weight is obtained. Then on the basis the residue left in crucible is ash and it is determined on the percentage basis. Then the formula is weight of ash formed upon weight of coal sample taken initially into 100. Then what is the significance of proximate analysis? First is moisture content. This moisture content decreases the calorific value of coal. It means it increases the cost of coal as well as the transportation charges. It increases ignition point of a coal sample. During the burning of coal, moisture in coal evaporates and take away some of the liberated heat in the form of latent heat of evaporation. Therefore, moisture lowers the effective calorific value of coal sample. Hence, higher percentage of moisture in coal is undesirable. Presence of moisture up to 10% in coal produces uniform fuel bit and less of fly ash. Then what is the importance of volatile matter? It decreases the calorific value, same as the moisture content. Then a high volatile matter containing coal burns with a long flame, high smoke and has low calorific value. Hence, for a better rank of coal, the volatile matter should be less. The volatile matter present in coal may be combustible gases, then non-combustible gases. Combustible gases like hydrogen, methane, carbon monoxide and other hydrocarbons. Non-combustible gases means nitrogen and carbon dioxide. Presence of these gases is undesirable as they don't add to heat value but increases the volume of the furnace required. Then the importance of ash content. Ash is useless non-combustible matter which is left behind when all combustible substances have been burned off from the coal. Ash content. Ash is useless non-combustible matter which is left behind when all combustible substances have been burned off from coal. It is undesirable due to the following reason: because it reduces calorific value of coal, it causes trouble during firing by forming clinkers which blocks the interspace of the grades on which coal is being burned. This causes obstruction to air supply. Therefore, the burning of coal becomes irregular. It causes hindrance to the flow of air and heat, thereby decreases the efficiency. It increases transporting, handling and the storage cost. Ultimate analysis, it is also known as elemental analysis. It involves following analysis. First is the carbon and hydrogen. In this, about 1 or 2 gram of coal sample is burnt in a current of oxygen or air in a combustion apparatus. You can see it's a combustion apparatus. Carbon gets converted to carbon dioxide and hydrogen combines with oxygen and form H2O. These gases are passed through the calcium chloride to absorb H2O, and KOH is also filled to absorb the carbon dioxide. The tubes are already weighed. Increase in weight of calcium, increase in weight of calcium chloride and KOH tubes after absorption of H2O and carbon dioxide respectively are determined. The reactions are involved. You can see in the reaction carbon dioxide and H2O pass through calcium chloride tube to absorb H2O and KOH tube to absorb carbon dioxide. It means filled KOH absorb carbon dioxide and filled calcium chloride absorb H2O and becomes hydrated calcium chloride 7H2O. What will be the formula of percentage of carbon? 12 upon 44 into increased in weight of KOH into 100 upon weight of coal sample taken. Then same as we can find out the percentage of hydrogen. H2 combines with half O2 and there is a formation of H2O, means 2 gram of hydrogen combines with oxygen and form 18 gram of H2O. This calcium chloride absorb it it means there is a formation or addition of 7 H2O. So percentage of hydrogen can be written as 2 upon 18 into increased in weight of calcium chloride or increased weight upon weight of coal sample into 100. You can also see in the reaction. Then next is nitrogen. Estimation of nitrogen. In this method, approx 1 gram of accurately weighed powdered coal is heated with the concentrated H2SO4 along with the catalyst potassium sulfate and copper sulfate in a long necked Zeldal flask. When whole nitrogen is converted into ammonium sulfate, a clear solution is obtained. It means nitrogen react with the H2SO4 and form ammonium sulfate, evolution of carbon dioxide, evolution of sulfur dioxide and H2O. When whole nitrogen is converted to ammonium sulfate, we are getting a clear solution. Then it is treated with the excess NaOH to liberate ammonia, liberation of ammonia and the formation of sodium sulfate. The ammonia thus produced is distilled over and absorbed in a known volume of V1 of the standard H2SO4. You can see the reactions. Nitrogen react with H2SO4 and there is a formation of ammonium sulfate. On the treatment with excess NaOH, it is converted into sodium sulfate. Then ammonia react with the H2SO4 and again there is a formation of ammonium sulfate. The volume of unused acid is then determined by titrating against standard NaOH solution. Let V2 ml of standard NaOH was required to neutralize excess acid. Thus the amount of acid neutralized by liberated ammonia from coal is determined. Volume of coal weight of coal sample is x gram. Volume of acid is V1 ml. Normality is N1. It means as the acid and the base always react in the equivalent proportion, therefore by applying normality equation, N1 V1 is equal to N2 V2. What is N1 V1? N1 V1 is acid and N2 V2 is ammonia. Now 1000 ml of 1N ammonia solution contain 17 gram nitrogen. It means it contains 14 gram of nitrogen. So V2 ml of ammonia solution of normality N2 contains nitrogen 14 upon 1000 into V2 into N2 gram. So we can find out the percentage. 14 upon 1000 into V2 into N2 upon X into 100. You can also see in the diagram also. Now, what is the formula of percentage of nitrogen? Volume of acid consumed by the liberated ammonia into normality of acid in which ammonia is absorbed into 14. 14 is the 14 gram of nitrogen, then into 1000 upon weight of coal sample taken. We can also write this formula as a volume of acid used into normality of sulfur. After calculating calorific value of a given sample by bomb calorimeter, during which sulfur is converted into sulfate ion, washing obtained from calorimeter, it means sulfate treated with barium chloride to precipitate out the sulfate as a barium sulfate. The precipitate is then filtered, washed and heated to constant weight. The percentage of sulfur is calculated as weight of barium sulfate is A gram, weight of coal sample is X gram, then molecular weight of barium sulfate is 233. Sulfur present in this barium sulfate is 32 gram. It means 32 upon 233 into A. Now, if you want to find out the percentage, it is multiplied by 100, then upon X. Then final formula of this, percentage of sulfur 32 upon 233 into weight of barium sulfate upon X gram into 100. Then the ash contained, ash determined is carried out as an proximate analysis, then the oxygen estimation. When the percentage of all other elements and ash present in the sample is calculated, the percentage of oxygen is calculated by the difference. You can see in the formula, percentage of oxygen is 100 minus percentage of carbon, hydrogen, sulfur, nitrogen and ash contained. Then the importance of ultimate analysis. Carbon and hydrogen in coal directly contribute towards the calorific value of the coal. Higher the percentage of carbon and hydrogen, it means it is better in the quality and its calorific value is higher. So carbon and hydrogen is desirable. Then what about the nitrogen? Nitrogen in the coal doesn't contribute any useful value to increase the calorific value, since it is generally present in the small quantities, but it doesn't have much significance than sulfur contained. Sulfur containing coal is not suitable for the preparation of metallurgical coke, as it is adversely affect the properties of the metal. Then the oxides of sulfur pollute the environment and leads the corrosion. The lower the oxygen content, the more is the maturity of the coal and greater its calorific value.